Okay, now that we've done the intro and did a little activity, let's start going over these to get ready for our next test on the first three kingdoms. We're going to start today with Kingdom Archaebacteria, Roman numeral 1. And archae means ancient. Now, I know you guys don't know this, but back in the 80s, when I was in middle school, the first two kingdoms of bacteria were actually classified together in a kingdom called Monera, and then they split them up, and I'll tell you why in a second here. Let's take a look at some of the basic characteristics. All Archaebacteria are unicellular prokaryotes. Now let's examine this word because we've talked about this before. Unicellular means one cell. Does anybody remember what prokaryote means? I know I can't hear you answer the question, but you could be thinking about it. This means no nucleus. So all of these organisms, one cell, no nucleus. Next. Now this is the characteristic in which taxonomists separated Archaebacteria from regular bacteria, which is the next kingdom. We'll do that tomorrow or the next day. This is the characteristic that separates them. Their cell walls, and all of these have cell walls, so they have a plasma membrane, then a cell wall, lack a very special protein called peptidoglycan. You don't have to know what that is. You just have to know that that's the fundamental difference between this kingdom and the next one. They are all heterotrophic or autotrophic. Now, we did these words in the ecology unit. Trophic means food. Auto means self-food. This means food from an outside source. So they either ingest their food or they can make their food. Either way. Just depends on the species. Next. It is thought that these may be the ancestors of eukaryotic cells. There's no solid evidence to this in terms of real proof, but there's a lot of research and data that would indicate that they might be the ancestors to our very own cells, which is pretty cool. All of these bacteria live in extreme environments, and as we go over them, you're going to see that right away. And when I mean extreme, I'm talking about so extreme that if you put regular cells in these environments that are not Archaebacteria, what happens to them? That's right, you guessed it, they die. Now let's take a look at the first example, and they're called Methanogens. Does anybody know what that is right there? Anybody know what that is? Well, we'll hold that thought. Anybody know what those are? From a redneck school, you know those are cows, so where's that going to fit in? Let's see. Characteristics of Methanogens. They are the largest group and the most common members of the kingdom Archaebacteria, no doubt. They are obligate anaerobes. Now let's investigate this word. And if you guys want to, you might want to take some side notes too. You know, get a piece of paper, watch this video a couple times, stop it. Because we're going to have an exam, and on the next exam, I don't want kids failing and getting D's on an online exam. I'm not there to watch you. It's online. We should be getting the best grades ever. Okay, sorry, I digress. I was preaching a little bit, but you guys know me. I do that in class too. Obligate anaerobes. Now, obligate, like obligation, you guys should know that word. If not, maybe read a book while you're home on your COVID adventure. Obligate means required. Can't be avoided. It is absolutely necessary. Or what happens? Well, this is real life. This is biology. If you use this word and you don't meet the requirement, you die. Well, not you. They do. Anaerobe. Now watch. Let me cover that real quick. Yes, here, there we go. I'm looking on the video too. There we go. Aerobe is a Latin word that refers to oxygen. Anaerobe is a negative prefix. So this means no oxygen. No oxygen. Required, no oxygen. For them to live, they must be in environments that don't have what? You guessed it, no oxygen. Now that's completely different from us. I mean, literally, how long can we live without oxygen? I don't know, 2.5 minutes. You could hold your breath with world-class training. I think the world record's near 7 minutes holding your breath without oxygen. Yeah, it's not long. But if they have oxygen, what happens? Gone. Obligate anaerobes. Now here's how some of them do. Here's where their name comes from. They convert carbon dioxide to something called CH4. Does anybody know what CH4 is? CH4? CH4? That is methane gas. What? Methanogens. Oh, they generate methane gas. Imagine that. Okay, we're going to come back to that in a second. Where do these guys live? Well, very common place, stagnant water. And you've all seen stagnant water. Like, water in an old pop can. It could be in a puddle in the middle of July. Could be a swamp that's pretty shallow and gets an algal bloom. Could be in an old tire that you find in the woods. Here's the reality. Guess what stagnant water is missing that regular water has? Oxygen. So stagnant water is without oxygen. If it doesn't have oxygen, then methanogens can grow there, which is pretty cool. Next, sewage treatment facilities. That is what this is. That is where, now I know most of you guys actually probably have sand mounds or some type of septic system, but if you had city sewage, when you flush the toilet, your stuff goes downtown into these big tanks, and then they process it, clean it all up, send that water right back to you. Doesn't that sound yummy? And where else? The intestinal tracts of animals. That's why I put these cows on here, which is very common. But there are also methanogens in your intestinal tract. And guess what there isn't in your intestinal tract? There's no oxygen. Now watch. These methanogens are anaerobic in your intestinal tract, and they make methane gas. Guess what methane gas is? You guessed it. That's the primary component of a stinker. How's that stinker? All right, and an example of this group is a specific species called Methanobac formicum. I'm not going to talk about them in great detail, but you can look them up online. Just remember, if you see this methano on the exam, wink, guess where it belongs? Methanogens. All right, let's go to the next group. B, the next group of Archaebacteria are called Acidophiles. And like that doesn't, well, it looks cool, but it doesn't look pleasant. Remember, extreme environments all the time. How do Acidophiles like it? Well, thermo is hot and acido is acidic. They like a low pH and a very high temperature. And when you look at these two things on normal living cells, what happens? Cells die. But not these guys. They're really good at living in extreme environments. Next, how hot do they like it? Between 140 and 176 degrees Fahrenheit. And I'm telling you right now, in those temperatures, you could burn your skin. And this is actually a hot spring in Yosemite. If you fell in there, you would not make it. It looks like, oh, I'll just go in there and swim around. Nope, you'd be cooked like a lobster. Next, how low of a pH? 2 to 4. Now, how does regular life like their pH? Somewhere around 7, like 6.4 to 7.4. Somewhere in there, that's where we exist internally and externally. But these guys like it extremely acidic, which would burn your skin, no doubt. Where do they live? Hot sulfur springs, which you can see in that upper right picture. They also live in areas of extreme acid mine drainage. It's got to be really, really bad. And obviously the EPA and around here, they've cleaned up a lot of this stuff from the 70s and 80s. And the last one, deep sea vents or anywhere there's underwater geothermal activity. I didn't have room for a third picture, so you guys can look that up. An example is any bacteria from the genus Sulfolobus. So sulfur, that goes with sulfur hot springs. I just wanted to give you guys a connector for the exam so that you're not trying to remember everything. Okay? And the last group are called extreme halophiles. And what does that word refer to? Well, if we were in class, we could always jump on the internet and do some etymology. But since we're COVID isolated here, I'm going to have to tell you. Boop. They like a high concentration of what? Anyone? Anyone? I don't hear any of you. Why can't I hear anyone? Oh, I know, because I'm in my basement. You're not even here. I'll tell you again. They like it salty, like a middle school girl. Salty. Okay, that's not funny. Yeah, it is funny. I'm sure the guys are laughing and you know what I'm talking about. Don't tell your mom I said that. Here we go. They like it really, really salty. So I have some pictures of some places on our planet that are extremely salty. So salty that when the water evaporates, it leaves behind the salt and it piles up. Does anybody know where these places are? This one's in the United States right there. Anybody know? Anybody know? Where do they live? They live in shorelines. Now, that could be anywhere. Anywhere seawater or ocean water comes up to the shoreline and then evaporates, that area is going to have that thin line is going to have a concentrated area of salt, but that's not the good ones. The good ones are these two. The Great Salt Lake, where's that at? Where's my geography buffs? That's in Utah, very good. And then the Dead Sea. The Dead Sea. That's around Jordan and Israel and, over in that area of the Middle East. So you can see these two bodies of water are really, really high in salt concentration. If you guys look this up online, look up the Dead Sea. You can float in there and read a newspaper, read a book. Like, you can't sink. It's crazy. It's like you're wearing a life jacket. But I wanted to show you some of these salt concentrated areas. So that is the end of the lesson for today, and we'll see you next time.